going to finish up text section 10.6 about conics. We had just a few examples left when we ended class last time. I want to finish up those examples starting with problem number 7. Number 7 asks us, and all of these ask us, to graph the conic section and find an equation for the graph. The first one talks about all points being equidistant from a point to 1 and a line y equals -3. On this one, because it is equidistant from a point and a line, this would be a parabola. So they're not going to tell you on these what the shape is. You should be able to determine that based on the information given. And it asks us to graph it and to find an equation. So I'm actually going to do the graph of it first because I have a little bit of information I can plot. So this is the point 2, 1. And then I have the line y equals -3. So y equals makes that a horizontal line. And here is my directrix, y equals -3. So halfway between these two locations would be the vertex of my parabola, so that's this point at 2, -1. And it would have to be opening upward in order for it to have the focus on the inside of the parabola. So since this is a graph that's opening upward instead of to the right or left, this is y equals. And we're going to have x minus something squared. The point that we're using for what we get here and here is the vertex point, which we decided was the point 2, -1. So the x value is, the x value is 2, so this is -2, and the y value is -1, so this is -1 on the outside. The only thing left to find, actually, is this value in front. And the value in front is actually 1 over 4 times the distance from our vertex to the foci, and the distance from our vertex to the foci is the number 2, so this is actually the value 1/8. And we have our equation of our parabola for number 7. On number 8, we have the description that we've got to find all points so that the sum of the distances from 0, 2, and 4, 2 equals 8. And the fact that the phrase is sum actually tells you that it is an ellipse. So we're going to do the same thing we did in the last one. We'll plot those 2 points. Those 2 points would be our foci. So we've got 0, 2, and we've got 4. I'm sorry, I plotted that wrong. 0, 2. So that's right here. And then we've got 4, 2. Right here. So there's our foci, and so halfway between the foci would be the center, and so that would be at 2, 2. So our center is at 2, 2, and that gives us good information about our graph. In fact, that lets us actually fill in some details. So since it's an ellipse, it's a plus, and an ellipse is going to equal 1 on the right-hand side, and this is y and x, and they're squared, and it's the center is at 2, 2, so this is -2 on each of those. The only thing I need to find now is the denominator of each of these. So it tells us that the distance here equals 8. And so when we're looking at that, what we're actually looking at is that that equaling 8 relates to the value of, in this case, in what I called A or B, depending on the problem. But it's the distance from the center, it's half of that, is the distance from the center out to the vertices. So this distance from the center here out to the vertex over here would be half of that value, which is 4. So that actually tells us that A in this case equals half of 8, which is 4. So we get 16 underneath. So my A value is 4. My C value clearly is 2. So if I'm using the equation that we had before, that means 2 equals the square root of 4 squared, which is 16, minus the B value that I'm looking for in this case. So this is 4 equals 16 minus B. So we can find out very quickly that B equals 12. So our equation is x minus 2 quantity squared over 16 plus y minus 2 quantity squared over 12 equals 1. Our last example actually has the same sort of description as the previous one, but it says the word differences instead of the word sum. So the fact that this is equal to distances, relates to differences, tells us that this is a hyperbola. Alright, so this is a hyperbola, and we'll plot the points that we're given. We're told that we have 2 points that are our foci. The points are at 0, 4 and at 0, -2. So here's 0, 4, and here's 0, negative 2. So halfway between would be the center, which would be at 0, 1. So our center is at 0, 1, and we can find that very quickly by using the picture to guide us. So the other thing that that tells us is that tells us as it opens up that halfway, I'm sorry, that this has it as this opens up, opens out, I guess you could say. It opens up and down because we're looking at a vertical description. So my graph is going to actually open up and down instead of left and right, which means that I actually have the y value, the x value listed first. So we're going to have x minus 0 quantity squared over something minus y minus 1 quantity squared over something, and this equals 1. Alright, I have these backwards, and I apologize in advance because I actually did these backwards in class today as well. If it opens up and down, my y should be listed first, not my x. It was right in my notes, it was wrong in what I was saying, and I do apologize for that. So this should be actually y minus the 1 quantity squared, and then x minus the 0 quantity squared on the other piece. Alright, so we have that fixed now. Alright, so let's take a look then at identifying our vertices. We've got our foci listed in purple. We've got our center listed in the blue, or colored in the blue. We need our foci, or our vertex, our vertices as well. And as we're taking a look at our vertices, that has to do with this fact that we've got equals 4. So as we're taking a look at that piece of information, that relates to where the center is located and how far away from the center that is, like on the last one when we did that divided by 2 on the ellipse. It's the same thing for hyperbola. That is actually going to be equal to our value a. So that's the distance that we are away from the center to each of our vertices. So we've got, I'll put it in red, our vertices. Our vertices are here at these two particular values, at -1, or 0, -1, and at 0, +3. And it's going to open up and down in this sort of an imagery. And that tells you the value that goes underneath the value for y minus 1 squared. So that actually gives you a 4 underneath here, because it should be this distance 2 squared to give me the 4. And then to find the other value, notice that my c value here is actually 3. So my c value of 3 has to equal the square root of the value 4, which was 2 squared, plus my value for b, and that's what I'm actually looking for. So as I'm attempting to solve this, this is 9 equals 4 plus b, so my b value, and it's actually b squared rather, but the b squared value then is going to be 5. So it's 5 that goes underneath the x minus 0 quantity squared. And you could, of course, simplify that and simply write it as x squared more concisely as well. So here's what we have for our last equation of our hyperbola.